All right, so before we take a look at questions 8, 9, and 10, which are going to give us two equations, each equation representing a line, and then we're asked to determine whether or not the two lines are parallel, perpendicular, or neither. And before we actually get into that, I want to talk about what it means to have parallel lines or perpendicular lines or lines that are neither, and how that relates to a line's slope. And so if we take a look here at the parallel graph that we're going to be making here, you'll be familiar with what parallel lines look like, and that's just two sets or more of lines that are, even though that doesn't look like it, two lines that are going in the same direction, and these two lines are never going to intersect. And that's because these lines have the same slope, and that's key to identifying whether or not lines are parallel. So if two lines have the same slope, so m is the same, then the lines are said to be parallel. Now if lines are perpendicular, that means one line is going to be going in a specific direction, and another line is going to intersect that first line and have a slope that is the opposite reciprocal of the first given line. All right, so that means that slopes are opposite reciprocals. And so what does that mean? Well, let's pretend that, for the sake of this example, that this line here has a slope of, let's just say, 3 over 4. Well, if this line here has a slope of 3 over 4, then a line perpendicular to that line is going to have a slope of an opposite reciprocal. So opposite refers to the sign, and I can go ahead and put that here. So opposite refers to the sign. So if the first slope we're comparing is positive, well then the opposite would be negative. And then reciprocal refers to actually flipping the slope itself. So here we're given a positive 3 over 4. So the perpendicular line to that will have a slope of negative 4 over 3. And similarly, if we were given a line with a slope of negative 4 over 3, then the opposite reciprocal slope of that would be changing the sign from negative to positive, and then reciprocal, meaning flip your fraction. So instead of negative 4 over 3, we end up with positive 3 over 4. And then, of course, if we have lines that are neither parallel nor perpendicular, then we'll have lines that are simply going in two directions. They do intersect, except the slope of, I don't know, the first line here again maybe is, 3 halves, and then the slope of the second line is, I don't know, maybe 2/5, something like that. All we're saying here with lines that are neither parallel nor perpendicular are that the slopes are not the same and they're not opposite reciprocals. And so when you have that, you end up with lines that are neither. All right, so again, just a quick example of, so maybe I should put down here, slopes are neither the same nor opposite reciprocals. All right, so that's just a quick refresher of what those lines look like, and hopefully that'll make it a little easier to go ahead and tackle these next problems here, 8, 9, and 10. And so the directions are: decide whether the pair of lines is parallel, perpendicular, or neither. And since we just talked about it, we know that the thing we want to look at with respect to equations of lines is the slope. And so we've been given two equations here, 3x minus 4y equals 17, and 8x plus 6y equals negative 6. And what we want to do is, let's put these equations, which have been given to us in standard form, let's put these into slope-intercept form, which you'll recall is y equals mx plus b. Because in this form, we are easily able to identify what the slope is, right? Because in slope-intercept form, m is our slope. And so if we can easily see what the slope of both of these equations are, then we can quickly determine whether or not they're parallel, perpendicular, or neither. So let's take this first equation here. So we have 3x minus 4y equals 17. All right, if we want to make this equation look like y equals mx plus b, meaning we want y on one side and everything else on the other, the first thing we can do is subtract 3x from both sides. And when we do that, we're left with negative 4y equals now negative 3x plus 17. And then finally, solving for y, we'll divide by 4x on both sides, or 4 rather, and we're left with simply y equals positive 3/4 x minus 17 over 4. And again, this is the equation written in slope-intercept form. So this and this are saying the exact same thing, just in two different forms. Except when it's in y equals mx plus b, we are easily able to see that the slope of this line is 3/4. So now what we want to do is take this second given equation, put it into slope-intercept form, and see what the slope is. So let's go ahead and do that. So we have 8x plus 6y equals negative 6. And again, if we want to solve for y, let's go ahead and subtract 8x from both sides. That's going to leave us with 6y equals negative 8x minus 6. And then we'll go ahead and divide by 6, and we're left with y equals. Now we have negative 8/6, which is going to reduce to negative 4/3x, and then minus 1. And so now we can see that the slope of the second line here is negative 4/3. All right, and so comparing these two slopes, we can see that one is positive, one is negative. So let's go ahead and, so we're looking for opposite reciprocals. So again, one is positive, one is negative, so we've met the opposite criteria. And now we have 3/4 and 4/3. Well, those are indeed reciprocals of each other, and so since they meet both criteria, we can safely say that these two lines are perpendicular. All right, so and really what you're doing is you're given two equations. You want to put these equations in slope-intercept form, y equals mx plus b, and that way you can easily identify what your m is, your slope. And from there, you should be able to determine whether or not the line is parallel, perpendicular, or neither. Let's go ahead and take a look at number 9 in the next video and get some more practice.